Hello to everyone. Welcome to my graduation project presentation. My name is Vakkas Doğan. I am an electrical and electronics engineering. We can start the presentation.
Hello to everyone. I am Vakkas. Today I will tell you about the work I have done in my graduation project. The name of my graduation project is Artificial Intelligence Based Android Assistance for Diabetes Patients. Firstly, my academic supervisor is Volkan Kılıç and my industry advisor is İrem Hilavin from Vestel. Also, this project has been supported by the Scientific and Technological Research Council of Turkey under the 229B Undergraduate Graduation Thesis Support Program with the application number of 1139B 411900770. On this page, I will talk about the content section. I will explain the motivation in the first part. In the second part, I will give information about diabetes. While doing the graduation project, we did two different studies. In these two different studies, we used machine learning and deep learning. Machine learning is the study of computer algorithms that improve automatically throughout experience. It's seen as a subset of artificial intelligence. Deep learning, also known as deep structured learning, is part of a broader family of machine learning methods based on artificial neural networks with representation learning. First, we did study called classification of blood glucose levels with multiple machine learning classifiers in diabetes patients, and in the second part, we conducted the study called smartphone-based blood glucose prediction with recurrent neural network using one of the deep learning algorithms, recurrent neural networks. Finally, I will explain the Android application called BFF Diabetes, the calculation and publications. Applications of machine learning algorithms in the health sector are increasing day by day. In the health sector, machine learning-based decision support systems are used in order to obtain more accurate results in diagnosis and treatments made by doctors to prevent human errors and to help to doctors' decisions. The president of Diabetes Foundation for 450 million people worldwide are struggling with diabetes, while in Turkey there are over 10 million diabetics. Applied scientific research in Turkey, according to data for 2015, shows that 1 out of every 12 people with diabetes, according to researchers, the number of diabetes patients will be 642 million in 2040. Is it scary? Do you think? I think it is scary. What is the diabetes? Diabetes is a disease that occurs when your blood glucose, also called blood sugar, is too high. Blood glucose is your main source of energy and comes from the food you eat. Insulin, a hormone made by the pancreas, helps glucose from food get into your cells to be used for energy. Sometimes your body doesn't make enough or any insulin or doesn't use insulin well. Glucose then stays in your blood and doesn't reach your cells. Over time, having too much glucose in your blood can cause health problems. I will talk about the classification study we did here first. The work will also be published at the second International Eurasian Conference on Science, Engineering and Technology. Or our aim in the study is to determine the critical values in diabetes disease known as hyperglycemia and hypoglycemia and to classify. Now, you see the flow diagram of the project. These are glucose measurement, dataset collection, and time series feature extraction, machine learning classifiers, and the last one is analysis of results. While doing this study, we did not have a real data set. That's why we decided to create synthetic data. We made this synthetic data by adding Gaussian noise filter to sine wave. Then, by finding the real data, we continued our studies with the real data. Synthetic data and real data are as shown in the figures. Time series feature extraction. While doing the classification study, the data we had was in a time-dependent series, and we had one parameter. We had to increase the number of parameters and make the data independent of time. That's why we made time series feature extraction. When we did so, we obtained the following parameters. These are clearance factor, class factor, impulse factor, cortices, mean, peak value, RMS, shape factor, skewness, standard deviation. Three important machine learning classifiers were used in this study. These are KNN and support vector mentioned secondly, and thirdly, decision tree. What is the KNN? KNN works by finding the distances between a query and all the examples in the data, selecting the specified number examples k closest to query, then votes for the most frequent label. Secondly, what is the support vector machines? Support vector machines is supervised machine learning algorithm that can be used for both classification or regression challenges. However, it's mostly used in classification problems. Thirdly, what is the decision tree? Decision tree is a decision support tool that uses a tree-like model of decisions and their possible consequences, including chains, event outcomes, resource cost, and utility. On this page, a sample graphic is given to show the range of label or class samples used during classification studies. For example, classification is made here using three labels. These are hypoglycemia, normal, and hyperglycemia as seen in the table. For example, if the number value is between 100 and 150, it's normal determined. When this value rises above 150, it's called hyperglycemia, while below 100 is called hypoglycemia. So, red lines indicate hyperglycemia, green lines indicates normal, and yellow lines indicates hyperglycemia. In here, classification is made using 5 labels or classes. These are hypoglycemia, pre-hypoglycemia, normal, pre-hyperglycemia, and hyperglycemia as seen in the table. The labels made and the names of these labels are as shown in the graphic. And in here, classification is made using 7 labels and classes. These are hypoglycemia, pre-hypoglycemia, post-hypoglycemia, normal, pre-hypoglycemia, post-hypoglycemia, and hyperglycemia as in the table. The labels made and the names of these labels are as shown in the graphic. For example, brown color indicates hyperglycemia. This page describes the results obtained for the classification study. The first table shows the results obtained for synthetic data. The second table describes the results obtained for real data. Considering the studies conducted, it was observed that the highest accuracy values in the dataset were obtained in the decision tree algorithm. In addition, as the number of labels increased, the accuracy values decreased. When we continue, the confusion matrix of the decision tree algorithm, which provides high accuracy for both data, is shown here. while green colors show correct results, pink colors show wrong. The second study on this page will be explained. The name of this study is Smartphone-Based Blood Glucose Prediction with Recurrent Neural Network. This work will also be published at the second International Eurasian Conference on Science, Engineering and Technology. In this study, studies were made on estimating blood sugar values by using recurrent neural networks. And in addition, the study is supported by Android application. When the flow diagram of the project is examined, glucose measurement was made first. The measured glucose values were stored in digital media. Second, the dataset was collected. This collected data were trained with RNN and LSTM, which are deep learning algorithms. These results are sent to Android application using the Firebase real-time database. You see the dataset used when making predictions. This is originally a real dataset. What is the RNN? RNN, which means that recurrent neural network. A recurrent neural network is a class of artificial neural networks where connections between nodes form a directed graph owing to temporal sequences. This allows it to exhibit temporal dynamic behavior. What is the LSTM network? LSTM is long short-term memory. Long short-term memory is an artificial recurrent neural network architecture used in the field of deep learning. Unlike standard feed-forward neural networks, LSTM has feedback connections. It can not only process single data points, but also entire sequences of data. A common LSTM unit is composed of cell, an input gate, an output gate, and a forget gate. The cell remembers values over arbitrary time intervals, and the three gates regulate the flow of information into and out of the cell. While doing prediction study, we would normally use TF-Lite to run in Android application, but we couldn't use TF-Lite with LSTM and RNN. So we got help from Firebase Industry Jet. Firebase is a mobile and web application development platform developed by Firebase. Secondly, Firebase Real-Time Database. The Firebase real-time database is a cloud-hosted database. Data is stored as JSON and synchronized in real time to every connected client when you build cross-platform apps with our iOS, Android, and JavaScript SDKs. As a result of studies, the results obtained using LSTM are as follows. The root mean square error is a frequently used measure of the differences between values sample or population predicted by a model or an estimator and the values observed. Root mean square error is 3.72. In statistics, mean absolute error is a measure of errors between paired observations expressing the same phenomenon. Examples of y versus x include comparisons of predicted versus observed, subsequent time versus initial time, and one technique of measurement versus an alternative technique of measurements. Mean absolute error 4.14, validation accuracy is 0.956 and blind test accuracy 0.942. As you see. We'll now watch the demo of BFF diabetes application.
First of all, hello everyone, I am Vakkas. Now I will introduce to you the Android application I made for the final graduation project. The name of the application is BFF Diabetes. As you know, the reason for naming this name, diabetes is a chronic disease and goes back to that with the patient. That's why I named BFF Diabetes, which means my best friend forever. We can say that. And let's log into the app now. When we enter the application, we encounter registration and login pages. If you are going to use it for the first time, you need to register the application. When press the No account yet, create one button, visit the registration page. In this section, you must create your username, email, and password. If you are already a member, you can log into the application by pressing the already a member login button. I already signed up for the application. That's why I log in directly to the application. Yes. When we log in to the application, we see such a screen. This screen is also the main screen of our application. On this screen, users can have information about diabetes disease. As you can see, both text and video are supported. If users want to get information about the video, they can watch it by pressing the play button on the video. We can even make an example if you want, like this. These videos are generally taken on YouTube channel. Let's continue. Now a shortcut menu has been created on the left for convenience. As you can see here, there are several sections. You can also add a profile photo the app. In addition, the email account you use to login also appears here. First, as you see, welcome ab@gmail.com. First, there is a homepage. As you can see, this is our homepage for the application. And secondly, after that, there is a diabetes or page. In order to have update information about diabetes, by entering here, the user can have up to date information on diabetes. This page is American Diabetes Association's page, as you see. Then there is a page showing the current blood sugar value of the user. Current stage page is here. The user is informed that he has hyperglycemia due to the high value. However, sad face emoji, which indicates that the value has increased, has been used. Here, a warning is given to the user. This warning is your current blood sugar value is increasing. Please be careful. And then the most important part for us is the predicted blood sugar value part. Here the results are taken, prediction states page. Here the results are taken at 5 and 10 and 15 minutes intervals, and within these results an increase was observed. As seen, these increases are shown as upward rising parabolic these increases are shown as an upward rising parabolic arrow. Here a warning is given to user. This warning is your current blood sugar value is increasing. Please be careful. On this screen you can also see sad face emoji. And let's continue. After that, there are alarm and reminder sections. With these sections, the user can make adjustments according to their own wishes. Let's see. This page is alarm page, and this page is reminder page.
And also there are communication parts related to application. In the lower parts there are features: share, follow us, inform us, such as there are features such as sharing the application, making requests and suggestions, and following us, as used to like this, and follow us page. This is follow us page, and inform us. Yes. Now there is a red button on the bottom right. This button is the transition button to other page. We can say that this button is next button. When we press this button, we see the current and predicted values simultaneously on the same screen. As you can see here, the values change according to the numbers they have. Since it is a risky value, it was colored red. Normal values are determined in green. And let's continue. The workflow diagram is prediction flow chart of the estimate value is shown below. When we go even further, there are graphical views for the real values and predicted values. These are blood glucose real graph, and this is blood glucose prediction graph. And also, one of the most important features of our application is notification sending process. So when the value goes over to 200, it sends a notice to the user. Let's test it now if you want. I close the app and send over 200 values from the sensor for now. When this value falls on the application screen, the user needs to send a notification. Yes, now I sent the value, and as you can see, the notification has arrived. If we click on this, notification will be the inside the application. Yes. Let's continue. Let's see all together. Yes, current state is 208. And also, so at the same time, the language option has been added to the application. Let's change the language if you want. There is a settings for the application. Firstly, language, and secondly, logout. Let's change the language if you want. Let's choose the Turkish language. When we choose the Turkish language, you see that the language has changed. For example, now we can repeat the language in English. Yes, I just loaded the library of Turkish language, so I don't try other languages. This is what I will tell with the application so far. Thank you for listening.
As a result of the studies, the following results were obtained. As you can see, and 2 conference papers are being written and with studies conducted at the second International Eurovision. The conference papers are being written with the studies conducted at the second Internal Eurovision Conference on Science, Engineering and Technology. These are smartphone-based blood glucose prediction with recurrent neural network and classification of blood glucose levels with multiple machine learning classifiers in diabetes patients, and this project has been supported by the Scientific and Technological Research Council of Turkey under the 22-9B undergraduate graduation thesis support program with the application number of 1139B for 119007770. Thank you for listening. Any questions?